Right. Let's say we have a ratio of red counters to green counters is 2 to 3. So the first thing in our sentence is red. So that's our first number, the 2. The second one in our sentence is green. That's the second number there. So 2 to 3. So that means for every 2 red counters there are 3 green counters. Like that. So if I add another 2 on this side, I'll have to add another 3. So what's that then? That will be 4 and 6. If I add another 2, that means I have to add another 3 on this side. What's that now? That's 6 on this side, and that is 9, and so on. All these ratios are equivalent, they're the same. So if I was given something like this, the ratio 8 to 12, and I wanted to simplify it, well, one thing I can do, check to see if you can half this number, half that number as well. Right, can I take it even further? Can I half this number and that number as well? Yes, I can. Look, I'm back to what I started with. But is there a quicker way to get from here to that number? Well, what's the biggest number that goes into 8 and 12? It's 4, isn't it? It's 4. Check, is 8 in the 4 times table? And is 12 also in the 4 times table? Yes. So divide by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So there you go, 2 to 3, 2 to the ratio of 3. Right, slightly more complicated problem here. Ratio of red counters to green counters is 2 to 3. So for every 2 red counters, there are 3 green counters. Second part of this paragraph, ratio of green counters to blue counters is 5 to 1. So for every 5 green counters is 1 blue counter. The question is now, what is the ratio of red to blue counters? So that's what we need to answer. We need a number for the red and we need a number for the blue. Well, you can't just say, oh, 2 to 1. It's not as easy as that. So how you go about tackling this problem is to look what they have in common. They've got green in common, but the numbers are different. So the first thing you do is find out what's the smallest number does that 3 and that 5 go into. If you can find the number, it's 15. Check. Is 15 in the 3 times table? Yes. Is 15 in the 5 times table? Yes. So now let's have a look. What I'll do now is I'm going to make 15 over here. So that's, every time I put 3 there, I'm going to have to put 2 on this side. Right, that does not make 15 yet, so I'm trying to make 15. That's 9 over here. Well, I'm going to put another 2 over there. Twelve. It's 15. Right, now I need to make 15 over here as well to match that. Every time I put 5 on this side, I need to put another 1 on this side. Put another 5 on this side. Put another 1. So now look, I've got my 15. 15 here, 15 here. That's what they have in common. So I don't want to duplicate information here. So I can just say 15. That's what they have in common. 15 is what they have in common. So how many counters do I have here? 2, 4, 6, 8, 10. How many blue counters do I have here? 3. So let's answer the question now. What is the ratio of red to blue counters? Red to blue, well, the answer is 10. 10 over here and 3 over here. I can safely say that because 15 is common to both parts of the ratio. I understand that you're not going to have counters to deal with when you've got questions like this. So ratio of red to green counters. Red to green, there you go, red to green, 2 to 3. And then green to blue, there you go, 5 to 1. So the word that is common to both ratios is green, but the numbers are not the same. So what is now the LCM of 3 and 5? The LCM of 3 and 5 is 15. Check. Is 15 in the 3 times table? Yes. Is 15 also in the 5 times table? Fine. So you need to change the 3 into a 15. So to change the 3 into 15, you need to times by 5. And then to change the 5 into a 15, you need to times by 3. 5 times 3 is 15, 3 times 5 is 15. So let's do this now. If you're going to times that by 5, you're going to have to times that by 5 as well. So 2 times 5, 10. 3 times 5, 15. 3 times 5, 15. 3 times 1, 3. So look, 15 and 15 is common. So to answer the question, what is the ratio of red to blue? Red to this blue over here, it's 10 to 3.